Hello everybody, Namaste. Welcome back to my YouTube channel. I'm Anushka, currently studying in Sri Venkateswara College of Engineering. Today we'll be discussing about structure and union, doing a comparison between them, studying about different data structures which will be useful in the programming language. Let's look at the differences between structure and a union. In structure, the keyword struct is used, whereas in union, the keyword union is used. Now, the keywords are important in order to distinguish between different data types, or perhaps different types of data structures which are being used. This helps us to differentiate between the structure and a union. The size. Well, let's compare the size or the size allocated. When a variable is associated with a structure, the compiler allocates the memory for each member. The size of a structure is greater than or equal to the sum of sizes of its member. So here, each variable, suppose we have two variables, x and y of different data types, int and char. Char usually in C has 1 byte, an integer depending on the processor, let's suppose it's a 64-bit processor, has 4 bytes. Here, now the total memory allocated would be 5 bytes. Whereas in the case of union, when a variable is associated with a union, the compiler allocates the memory by considering the size of the largest memory. So here, the memory space is shared between different variables. It could be understood as a property of the family, which is shared between different siblings, and the eldest sibling might get the largest part, and the other siblings, depending on their age or seniority, gets different parts. Whereas in a structure, there's no such type of inequality. It is basically based on what their capabilities are. Memory, each member within a structure is assigned unique storage area of location, and each variable gets its own memory. Memory allocated is shared by an individual member of a union. Altering the value of a member will not affect other members of the structure as the memory is not shared, whereas altering the value of any of the members will alter other member values as the memory location or the memory space is being shared. Individual members can be accessed at any time. Only one member can be accessed at a time. Several members of a structure can initialize at once, whereas in a union, only the first member of a union can be initialized. Now let's have a comparison here. There's the structure keyword struct. EMP is our structure. We have two variables here, x and y. X is char, like the data type is character, which is represented with a char, which has a byte one size of memory. Whereas in the other hand, we have y with the data type float. Float has the size of 4 byte. And then we close the braces. This is the flower braces, which shows that the structure is closed. And then E shows the structure variable, which can access the structure members X and Y. So the total memory here is 5 bytes. Whereas in the case of union, union is the keyword, EMP is the union, and we have the flower brackets open and close. We have X and Y variables again, character for X, float Y. Here, the largest memory space is of Y, that is 4 bytes. So there is memory sharing, and the memory of the total union is 4 bytes. Allocate storage equal to the largest one. Again, here is the union variable. But the only difference between structure and union is structure allocates different memory to different variables, whereas union, there is a shared memory where the largest memory size of the variable is shared among the others. Now we'll be looking into introduction to data structures, which play a very important role in any programming language, and these are the basis to any programming language. Data structures are essentially for organizing and managing data efficiently and effectively. They are the building blocks, as I mentioned earlier, of various applications and algorithms, providing efficient ways to store and retrieve data. So we have classification of data structures. We have a data structure. We have linear data structure and non-linear data structure. In linear data structures, we have two components, static data structure and dynamic data structures. In static data structure, we have array. In dynamic data structures, we have queue, stack, and linked list. Today, we'll be looking at queue, stacked, and linked list. In non-linear data structure, we have a tree and a graph. Overview of stack data structure. So basically, stack is a linear data type which follows the principle of last in, first out, or first in, last out. So LIFO principle. Stack follows the last in, first out principle, where the last element added is the first element to be removed. Operations. Stack operates two main operations, which is push to insert an element and pop to remove an element. So implementation of stack, push and pop operation. The push operation, push adds an element on the top of the stack, whereas a pop removes the element at the top. Sorry, pops removes the top element from the stack. As mentioned earlier, the last element to enter is the first element to be removed. We're looking at the abstract data type, that is ADT of stack. Now, abstract data type is basically an overview of all the operations performed on stacks. Here, one thing to be remembered is two conditions, overflow and underflow. Before inserting or before pushing an element, you should always check whether the stack is empty or full. If it is full, then you will encounter the situation of overflow. If it is not full, or if it's empty, you will encounter the situation of underflow. Or rather, when you're popping out an element, that is removing an element from a stack, then you need to make sure that the stack is not empty. If is not empty. If it's empty, then you'll face underflow. So when you're putting an element into a stack, make sure that the stack is not full. And whenever you're popping out an element or removing an element from a stack, make sure that the stack is not empty. Now let's look at the ADTs. Insertion and deletion is the main. Follow the last in, first out scheme. Think of as a spring-loaded place dispenser. Main operations is push to push an object, pop to remove an object. Then you have auxiliary stack operation, object top returns the last inserted element without removing it. Integer size returns the number of elements stored, and boolean is empty indicates whether no element are stored. If it is empty, that is, if it is true, that means it is empty and you cannot pop any element out. Otherwise, you will encounter underflow. Now, if it is false, that means there are elements inside the stack and you can remove the elements efficiently. You also have boolean is full, where it gives true or false. If it is true, that means the stack is full. That means you cannot push an element into the stack. You will encounter overflow. Let's look at queue. A queue basically follows FIFO principle. Now, what is FIFO principle? It is first in, first out. The element that goes in first is the one that is removed, whereas in a stack, it is last in, first out. That means the element that goes in last, the one that pops out, or is the one that is removed. You follow the first in, last out principle, which is also known as last in, last out, where the first element added is the first to be removed. So we have supports two primary operations. Like in stack, we have your insert to add an element and delete to remove an element. One thing to note is a queue has two ends, the rear end and the front end. The rear end is where the element is inserted and the front end is where the element is. Now let's look at the abstract data type of queue. The definition of queue is it's a restricted list where all addition occurs at one end, that's the rear, and all the removals occur at the other end, that is the front. This strategy is known as first in, first out strategy. The operation methods on queues are enqueue items, insert items at the rear of the queue, dequeue, remove the item from the front of the queue, size, returns the number of elements in the queue, empty, returns true if the queue is empty. Again, here, the elements can only be removed if there are some objects present in the queue. Now, if you try to delete an element out of queue, if it is empty, then you'll undercome underflow. So if you would like to delete an element from the front end, you need to make sure that the queue is not empty. Full returns true if the queue is full. Again, if you'd like to add an element on an object in the queue, make sure that the queue is not full. the objects are added from the rear end. So you need to first operate full. If the full returns the value true, that means you cannot add elements. And if you go on to do so, then you'll encounter the condition known as overflow. Front returns the item at the front of the queue without removing it. Implementation of queue, insert and delete operation as mentioned earlier. Insert adds an element at the rear of the queue and delete removes the element from the queue. Let's look at the linked list. So we have two types, dynamic structure and node-based. Dynamic structure, a linked list is a dynamic structure that can grow or shrink in size during the execution of the program, whereas a node-based, it consists of nodes where each node contains a data field and a reference or link to the next node. So implementation of linked list has two operations, insert and delete. Now, let's have a comparison between the three, stack, queue, and linked list. Performance, stack and queue are faster for insertion and deletion, while linked list is efficient for searching and accessing members. Usage, stack is used for function calls and parsing, queue is for scheduling, and linked list for memory management. Use cases and application of stack, queue, and linked list. Stack used in undo functionality, expression evaluation, and backtracking algorithms. Queue applied in breadth first search, print spooling, and CPU scheduling. Linked list utilized in memory allocation, symbol tables, and representing polynomials. Conclusion and key takeaways. Importance. Understanding data structure is crucial for designing efficient algorithms and developing high performance applications. Application diversity. Each data structure offers unique characteristics that make them suitable for specific scenarios and problems. That's it for today. I hope you guys learned something and got some knowledge out of this video. See you guys in the next one. Thank you.